Welcome to another episode of the Scannell Agenda. Today's date is Friday, April 4th, 2014. This is show number 15. So spring is here. It's a beautiful day. I want to explain some of the basic principles of the work I do. And I have mentioned it, but I do think I have solved the energy crisis. And I know I'm just a fisherman and a boatyard worker, but as I said, you know, the brass ring is there for anyone to grab. If you can solve it, then do it. I think I have. Now, the theory is, let's say, in about 5 parts. And I have it written up here. 6 themes. I'm sure there's more. But the basic themes are that with wind energy, as a general truism, as a cardinal rule, basically, you have to go up where the wind is. Let's say for our purposes here on the Cape and, you know, the Georges Bank mega mill system. There's somewhat okay wind down lower, but really if you want to go where the money is, you go up, up, up. And that's where the wind is or where the money is, as I say, because I think that's my fishing background. So you got to be big to go tall. So big and tall is one of the themes, and that requires much more refined gear than just a stick. You know, what we typically think of as a windmill, I think of as a toy. So here's the ground, and you have your, you know, you have your windmill here. Well, you know, that's I suppose okay. You know, I like the little windmill at the Mass Maritime. It's very nice, and they making it pay, and it's worthwhile, and it's nice to look at, and I hope it's not bothering anybody. But that's okay, but it's not where we're going to end up as far as I'm concerned. We're going to end up with very, very big systems that produce for their own grid, let's say. And I'll get to the grid. Okay, so you got to go big and tall, and that means almost unimaginable scale, but we got to do this. It's got to be bigger scale. These little toys, as I call them, not to insult them. It won't get us to where we need to go. All right, now the other theme in the work I do in designing these systems is a stick and a base. Okay, and you've seen me do, you know, this. Well, here's the base and here's the stick. It's very simple. You could even picture a telescoping, any kind of a telescoping 2-part. It's not too complex. You use a lot of complexity in the cables to bring the stick up and down. And the reason why you want to go up and down is because there will be storms. And you want to be able to, as I say, hunker down for those storms so that your wind systems don't have to be designed to be so heavy duty. To design wind systems for, let's say, 180 mile an hour winds aloft, it would be very expensive. So it's much cheaper to use, you know, use your noggin and create a rig that will protect itself against extreme winds. So stick and base, that's another theme. So regarding the stick and base, you will need extensive what's called standing and running rigging. So on a sailboat, the standing rigging will hold up your mast and it will go down to the chain plates. And then your running rigging will be all the adjustments to your sails and bringing up and down your sails and gaffs or whatever your rig is. That's the running rigging. So these Georges Bank mega mills have extensive standing and running rigging because in order to go up and down with all these huge systems, you've got to have that. Okay. Now the other theme is the production of green fuels. So we'll be producing, let's just say offshore or in a demonstration project, we would be producing hydrogen using electricity on the spot to generate the hydrogen and oxygen, of course, too. That turns into oxygen-rich compressed air. Now, some of these, you might think, oh, this will be expensive on a per windmill basis, but you can tie multiple windmills using hydraulics into one electrical system using hydraulics and flywheels. That's more my speed. Or if you're generating compressed air, what I do is I have a conveyor belt that carries air down to depth, down to the deeper parts of the ocean, and that's where it's, you know, sort of naturally compressed. That's my style of, and these are very basic, doable, cheaper, let's say, than trying to, it's an impossible dream, but if we littered Georges Bank and some of our offshore areas with big standard windmills, in other words, the toys scaled up to a bigger size or modified somewhat with better bases, you know, we could do that. However, the problem is the electric grids are incongruent with that thinking, because you can't load your grid up on a northeast wind and then have everybody shut down and then, okay, it's not windy anymore, you guys can start up again, you know, with your plants. These guys, they don't operate that way. It's just not doable. The thing that makes these green fuels doable is that it's stored energy from the wind. That's big. So that's the common denominator too between the old and the new, these new green fuels. So production of green fuels, hydrogen, compressed air, and when I say 8,000 psi on the compressed air, what we're looking at is that's your main line, your high tension wires. You may think of that. You wouldn't have that kind of compressed air, of course, in a neighborhood or in your household to run your refrigerator. These pressurized systems can run refrigeration, air conditioning. They can help to run mechanical things like your dryer and washing machine and that kind of thing. And I see every house being plumbed in with these green fuels because, and that gets us to the next phase in concept here, the tripe system, as I call it, which stands for track, TR, pipe. Okay, IPE, there you go, track pipe or tripe. By the way, the youngsters don't mind that. It's the older people that say, oh, they get all twisted up in a bundle. Why'd you have to go, you know, and that's where everything stops. So that's ridiculous, but some people have their little problem with tripe. My mother never let me have any tripe in the store, and then finally she got pretty cross with me when I was insisting on it. I think I was 3 or 4 years old. Can we have that? You know, look nice. And anyway, it's a plumbing system, and our own intestinal systems, or an animal's intestinal systems, which is known as tripe as a food, let's say, well, not, you know, unless you're a cannibal. Anyway, in a way, this tripe system will be everywhere. There'll be monorails everywhere to carry utilities and energy, a lot of utilities and a lot of energy, and transportation, so it's a mega system. And I really think that killing 2 birds with 1 stone with these systems that I work on is really the answer. Because if you built a monorail system and you did use a pipe, which would make sense, and you'd have to pay for that pipe with your transportation system. But basically, the monorail systems that I design, most of that expense, insofar as the pipe goes, will be carried by the energy systems, the utility systems. It's kind of a do-it-all system, which is a tremendous achievement, if I am right about this, it would be a tremendous achievement for the world. It would get us eventually off of the fossil fuels and onto the green fuels in a phased approach, which is also, you know, we wouldn't have to shock systems, financial systems, energy systems. It wouldn't be a shock. It would be phased in properly. Now, I have something else which is fundamental, and that is a consortium model. It's a business model for a project such as this. It's a worldwide mega project. It's an energy system. It's a transportation system. These are huge. And then it's utilities go in these pipes. So natural gas, broadband, water, sewage. It's a huge mega system whereby, you know, we put things in this pipe, and the pipe is also used as a monorail or the wide gauge rail systems as well. So these are all the fundamentals or themes of the theory. The theory being is, yeah, we can do the green energy. We don't have to do the fossil fuels. And a lot of people agree with that, but it's hard to get from here to there. Well, this is the how-to, get from here to there. All right. So I'll discuss now something I call the Nauset mill, which is kind of it's not a mini version of the Georges Bank mega mill, but it has a lot of the same attributes. And if you look here, and I'll probably put this stuff online if anyone starts watching this show, but I'll darken up these copies so that you can see the whole thing. The Nauset mill has a base like a mushroom anchor. Now, as I just explained, these 6 themes, as I call them, are the basis of, let's say, all the bridge designing that I'm doing with the new middle bridge, or whatever we want to call it there. And if these don't make sense, then the whole idea about the windmill bridge designs with the pavilions, etc., then none of that makes sense either, because everything's built upon these foundational themes or theories. And I've been working at this for a number of years, and I do believe I've solved the energy crisis. I think it was out there for anyone to solve, and I think I've solved it. But of course, this will take a lot of work and time and major effort from the world to do this whole project, which is probably the biggest infrastructure project the world has ever known, if it does happen, and I hope it does. Now, I want to talk about what I call the Nauset mills. The Nauset mills are kind of a scaled down version of the Georges Bank mega mills. And if we would like, we can build them here, local industry. Now, what you see here is this is your base here, and this is the stick, and this is a windmill. You don't see the top windmill part. This is a base cap, and these are cables that go down to helical anchors or helix anchors. And your water line would be about here. So most of this stuff that you're looking at would be underwater. So the mushroom anchor part is down here, and these pieces all fit together with threaded fittings. And then your your grade or your bottom of the ocean would be about, whoops, bottom of the ocean be about right here. These are like a boat stand. These are 4 or 6 legs, and this is a fitting here that has threads, so this would thread into that and thread into that. And then what I didn't mention here was down below you have a big pipe going way down. As I have it drawn up, it's a 40-foot by 150-foot basement, I call it, because the stick, the whole theory is to go high you got to go low, and your stick wants to come way down into the sediments where we will hunker down from great winds. So that's that. Now, last week we looked at the possibility of a Barnstable County, Cape Cod Canal ship and bridge works out at the east end of the canal. And I showed you this last week. And in the newspaper today, front page headlines is global warming effects and, you know, the sand on Sandy Neck. And here you see, of course, I have drawn in a huge deposit of sand, which there is a harbor that goes in here that would come through. I didn't draw that in. And then you've got this tender vessel here for the installation. It's a huge vessel for the installation of these Nauset mills. That is now this is just very fundamental, rudimentary drawings, you might say. Here's a tender vessel, probably over 1,000 feet long, and those little circles up on the bow of the boat would be your where you put your parts, and there's a lot of parts, and they'd all come together out there offshore, or and then you'd plant them in, which would be no small undertaking, but I'm sure we can get good at it. It's not that complex. So the Nauset Mill construction would be done at the Cape Cod Canal. And again, I have envisioned a lot of people participating, the Bath Iron Works, a lot of people from New Bedford and Rhode Island, you know. There's a lot of expertise up and down the coast here, from Maine to, you know, New York, Connecticut, and people do need jobs, and this is really a huge jobs generator, a project like this. But I wouldn't call it a jobs program, okay? This is all productive work, I'm thinking. Of course, it would all have to be costed out, cost benefits would be done. Now, we could build this little Nauset mill, these Nauset mills. We could build them probably out of ferrocement, and they'd have a lot of labor involved with just the tire reefs that would be connected to these windmills. In other words, it would be a massive tire reef project. And probably we'd have the wave generator gear there too. I've got a lot of these things drawn up with the gear that will tap into the wave energy, which is substantial. So these are all, then you have to get your parts list, and then you have to keep perfecting it and making models and doing prototypes and computer models, and this is quite a project. And what I'm not really getting into discussions of is a lot of details about the stick and base construction. I have a lot of ideas about that. Here I have 50-foot diameter sticks that go down into these 80-foot diameter bases. And these might be good for the demonstration project at the canal. And if you can see, that right there would be a stick, and that's steel pipe. 7 steel pipes. pretty strong units, welded together. And if you wanted to be fancy, up at the top, all my Georges Bank mega mills have these top mills, I call them, because you've got an extensive running rigging up at the top of your sticks. As well, the bases have all this rigging. That's mostly your standing rigging at the bases. So here you'll see a band of windmills here, probably 9 deep or 7 deep. In other words, an array. And then, there'd be breaks for the navigation. There's the Nauset Inlet. There's Chatham. And there's Monomoy Point. I've got that a little shortened up, of course. It doesn't pass for good artwork at all. So this is a brand of windmill that I call the Nauset Mill. And it's very closely related to the Georges Bank mega mill. Here I have a drawing of a bridge deck that would be over the land heading into Route 25, which turns into, let's say, excuse me, 495, and so there'd be a lot of financials to contend with, but I can see in my mind's eye the under the bridge parts works if we build these Nauset mills out of ferrocement and steel and some wood, plasticized wood most likely, and then, because you've got threads and things are all threaded together. So in my imagination, you would have the Love Power Grid Consortium would be the main financial vehicle, legal vehicle for this huge partnership, which would be started here on the Cape, that I call the Love Power Grid Consortium. Now that's in the report that I did in February 2010, and that's the tripe system report. And so, just out of my imagination, Springfield Rebar Works Incorporated, you'd have people coming from parts unknown here in Massachusetts. Amherst Prototype and Research and Development Company Incorporated, you'd have a lot of participation. Gloucester Tire Reef Works Incorporated. Hope I'm not. And there's Newport Rigging Companies would come in. New Bedford Rigging and Staging Companies, and it'd be a huge project. But as I say, it's not a jobs program. I mean, we need energy systems, utility systems, and transportation systems. As I mentioned on a show earlier, our rail systems derive from the distance of the gauge. The 4/8 gauge comes from the Roman times. If you can believe that, it is true. But these systems, these rail systems that we use now, they're okay, but they are 200 years old in design. So if we were to design a new rail system for the world, what we would be doing would be really moving the world forward with transportation, efficient transportation systems designed for the new world, the new green energy world, that's required, And when I looked at this global warming issue many years ago, I said, this is real. I didn't need to twist my arm, and I wasn't confused about this. I never was. In the earliest days when this first came out, I said, this is real. We're going to need to shift away from these fossil fuels and pollution. And so I started working on this many years ago. So a lot of the work I do is designing these stick in base. And some of it's grandiose, you might say. Here's one that's pretty big. This is something recently I've drawn up, and it is a square stick modular base, and it's got directional strength written in there. So I've actually designed the base to be a building. That's the base. Excuse me. This is the base, and it's all steel. It's designed for the plains, you know, everywhere from Texas up to the Dakotas and into Canada. And in here you've got a smaller square stick, and that's what that is. That's a stick that goes up and down. That's a theme. Now you can do it hexagonally. That might make more sense. But this here is 300 feet across. 300 feet across. So you need to be substantial to go big and tall with these rigs and to get up where the money is, where the wind is. Okay. So, all right, now I want to shift gears and talk about this new bridge, or the middle bridge, I'll call it here. One of my latest drawings is of a hanging pavilion here. Now this hanging pavilion is made up kind of like, it looks just like the, except it's got floors for your people. So what you're looking at here is a huge pavilion. These are 20-foot diameter plastic pipes, all bound up together. High-tech. These are the floors. The people will look down on the bridges and the canal and all the tall ships. And this is your hanging gear to hang these, this pavilion up. So on the next show, I'll really get into that. Okay, all right. I think what I'll do is pretty much wrap up this show here and get into my next show talking about the this grandiose project for the new bridge on the canal, which it encompasses all the work I've done for many, many years with the windmills. And it'd be huge for tourism, huge for our technology, for the world's technologies. Okay, thanks for watching the Scannell Agenda.